This is number 13 from the practice set from the text. This one has some pretty tricky algebra in it. You're going to use the same type of thing on number 17, same type of algebra idea. So I thought it would be good to do 13 with you / for you. So again, we start with the sequence, or I'm sorry, it's a series since everything's being added together. We have an equation for the series that we're going to prove works. I'm going to start showing that n equals 1 is true. So that means, again, we're just saying this is equal to this guy for n equals 1. So I have 1 squared, and I want to show that's equal to 1/6 times 1 times 1 plus 1 times 2 times 1 plus 1. That gives me 1/6 times 2 times 3. Since 2 times 3 is 6, 1/6 times 6 is 1. Our n equals 1 case is true. Now we're going to assume that k is true and show that k plus 1 is true. Okay, so I have my statements written. My if-then is all written. You will notice that on the left side or on the right side of my equation, I have replaced all of these k's in my then statement with k plus 1. So 1/6 k becomes k plus 1. This k became k plus 1. And this k became k plus 1. You don't really need all of those parentheses. I use them because it helps me replace things. If you want to, you can kind of sketch in, this guy is actually k plus 2. It's going to make it easier for you to see your algebra on the other side. This guy is 2k plus 2 plus 1, which is actually 2k plus 3. So just like when we were doing trig proofs, we're only working with one side of the equation, but you should look at the other side, look at your goal, be comfortable with where you're going. All right, so now's the time to make our swaps. We know from above that this whole thing is equal to this. We're assuming that's true. Down here in our then statement, that is this bit here through k squared. So I can replace 1 squared, 2 squared, 3 squared, ... k squared with this 1/6 k situation. And then the only thing I have left that I haven't brought down from my then statement is this k plus 1 squared. I'm not going to rewrite the goal every time. We know what it is. We've worked with it a little bit. Now here's the tricky, well, there are a couple of tricky parts of this algebra. But what you want to be looking at as you're looking at both sides of the equation is things that you can factor out kind of creatively. If you look at what we have going on here, I have k plus 1 in both of these terms. And these are two, this really at this point is just two terms. The term with the 1/6 out front and the k plus 1 squared. They're separated by that addition sign. So if we have anything that's the same in both of those terms, we can factor it out. And what we have is a k plus 1 in common. So I'm going to factor that out. And that's going to make my situation easier. The other thing, and the reason that I thought to do that, is that as I'm looking at my goal, k plus 1 is part of my goal. So I'm going to factor that out. Everything else is going to stay the same in the parentheses. So the k plus 1 goes out front. And then everything else stays the same. I'm going to put it in brackets just because that kind of helps me organize my work. I have 1/6 k times 2k plus 1. That's what I had left from my first term. Plus, I had a k plus 1 squared. I pulled out a k plus 1. So I have k plus 1 left. Now, it would be great if we could factor from here, but what we really need to do is work in our brackets here and get everything multiplied out. I know I'm going to 1 and 1/6 on the outside, so when I multiply this 1/6 through, I'm not going to reduce anything. So I'm going to multiply this 1/6k through. That's going to give me 2/6 k squared plus 1/6 k. And then I have this plus k plus 1. And I have the k plus 1 on the outside that I just need to bring down. Now I want the 1/6 on the outside. So I need to combine like terms now. Here on the inside of my brackets, I have 1/6 plus 1. And if it helps you to make that into 6/6, that's awesome. That gives me 7/6 k. Everything else is going to stay the same. I'm also going to go ahead and change that 1 into 6/6. And what that's going to let me do is very easily factor out the 1/6 at this point. Remember, our goal is to have 1/6 out front. So I'm going to factor out the 1/6. It's going to come out in front and be with the k plus 1. What's left in my brackets is everything, basically all the numerators and the k's. So I have 2k squared plus 7k plus 6. So a couple of things that I think were tricky up to here. One was factoring out the k plus 1 from the beginning. And 2 was getting that common denominator situation in this step here, so that you could factor out the 1/6. So anytime you have a fraction on the outside, and that will happen in several of these problems, kind of getting a common denominator is really helpful for helping you factor that out. Now we just need to factor our what's in our in our brackets here. We need things that multiply to 2 times 6 and add to 7. So that would be 3 and 4. And you guys should be factor masters at this point. I'm just going to bust through this really fast. So in our brackets now, we're going to replace our brackets with parentheses. It'll be 2k plus 3 times k plus 2. And on the outside of our brackets, we had 1/6 and k plus 1. That doesn't exactly match the other side of our equation. We had a couple little things that we kind of played with to make this match. So let's go back and look at those on our second page. So we were looking for 1/6, k plus 1, k plus 2, 2k plus 3. And I believe that's what we have right now. Let's push forward again. Yep. So our goal was 1/6 times k plus 1 times k plus 1 plus 1 times 2k plus 1 plus 1. And the way those match up is like this. Well, clearly these two are the same. The first two match up exactly. This guy is here. That guy is there. So again, you would end your proof by saying QED, or that we satisfied conditions 1 and 2, and therefore the statement is true. So you're going to use a similar algebra to this when you work through number 17. So be careful with that one, and make sure if you need to look back at this one, you do that.
Made with Doodlecast Pro.